What is physics? Physics is a basic discipline in the category of natural sciences, which also includes other disciplines like chemistry and biology. The word physics comes from a Greek word meaning nature. Its Sanskrit equivalent is bhautiki, that is used to refer to the study of the physical world. We can broadly describe physics as a study of the basic laws of nature and their manifestation in different natural phenomena. The scope of physics is described briefly in the later section. Here we remark on two principal thrusts in physics: unification and reduction. In physics, we attempt to explain diverse physical phenomena in terms of a few concepts and laws. The effort is to see the physical world as manifestation of some universal laws in different domains and conditions. For example, the same law of gravitation given by Newton describes the fall of an apple to the ground, the motion of the moon around the earth, and the motion of planets around the sun. Similarly, the basic laws of electromagnetism, that is, Maxwell's equations, govern all electric and magnetic phenomena. The attempts to unify fundamental forces of nature reflect this same quest for unification. A related effort is to derive the properties of a bigger, more complex system from the properties and interactions of its constituent, simpler parts. This approach is called reductionism and is at the heart of physics. For example, the subject of thermodynamics, developed in the 19th century, deals with bulk systems in terms of macroscopic quantities such as temperature, internal energy, entropy, etc. Subsequently, the subjects of kinetic theory and statistical mechanics interpreted these quantities in terms of the properties of the molecular constituents of the bulk system. In particular, the temperature was seen to be related to the average kinetic energy of molecules of the system. We get some idea of the scope of physics by looking at its various subdisciplines. Basically, there are two domains of interest: macroscopic and microscopic. The macroscopic domain includes phenomena at the laboratory, terrestrial, and astronomical scales. The microscopic domain includes atomic, molecular, and nuclear phenomena. Classical physics deals mainly with macroscopic phenomena and includes subjects like mechanics, electrodynamics, optics, and thermodynamics. Mechanics, founded on Newton's laws of motion and the law of gravitation, is concerned with the motion or equilibrium of particles, rigid and deformable bodies, and general systems of particles. The propulsion of a rocket by a jet of ejecting gases propagation of water waves or sound waves in air, the equilibrium of a bent rod under a load, etc. are problems of mechanics. Electrodynamics deals with electric and magnetic phenomena associated with charged and magnetic bodies. Its basic laws were given by Coulomb, Oersted and Ampere and Faraday, and encapsulated by Maxwell in his famous set of equations. The motion of a current-carrying conductor in a magnetic field, the response of a circuit to an AC voltage, that is signal, the working of an antenna, the propagation of radio waves in the ionosphere, etc. are problems of electrodynamics. Optics deals with the phenomena involving light. The working of telescopes and microscopes, colors exhibited by thin films, etc. are topics in optics. Thermodynamics, in contrast to mechanics, does not deal with the motion of bodies as a whole. Rather, it deals with systems in macroscopic equilibrium and is concerned with changes in internal energy, temperature, entropy, etc. of the system through external work and transfer of heat. The efficiency of heat engines and refrigerators, the direction of a physical or chemical process, etc. are problems of interest in thermodynamics. The microscopic domain of physics deals with the constitution and structure of matter at the minute scales of atoms and nuclei, and even lower scales of length, and their interaction with different probes such as electrons, photons, and other elementary particles. Classical physics is inadequate to handle this domain, and quantum theory is currently accepted as the proper framework for explaining microscopic phenomena. Overall, the edifice of physics is beautiful and imposing, and you will appreciate it more as you pursue the subject. You can now see that the scope of physics is truly vast. You can now see that the scope of physics is truly vast. It covers a tremendous range of magnitude of physical quantities like length, mass, time, energy, etc. At one end, it studies phenomena at the very small scale of length, 10 raised to the power minus 14 meter or even less, involving electrons, protons, etc. At the other end, it deals with astronomical phenomena at the scale of galaxies or even the entire universe, whose extent is of the order 10 raised to the power 26 meters. The two length scales differ by a factor of 10 raised to the power 40 or even more. The range of time scales can be obtained by dividing the length scales by the speed of light, that is 10 raised to the power minus 22 second to 10 raised to the power 18 seconds. The range of masses goes from, say, 10 raised to the power minus 30 kg, mass of an electron, to 10 raised to the power 55 kg, that is, mass of known observable universe. Terrestrial phenomena lie somewhere in the middle of this range.